Dear students, in the last class, the topic that we had discussed was uniform circular motion. So, what is uniform circular motion? Motion of a body in a circular path with constant speed is called as uniform circular motion. The angle through which the radius vector rotates is called as angular displacement, denoted by theta, measured in terms of radian, and rate of angular displacement is called angular velocity, denoted by omega, which is given by theta by t, or you can even write d theta by dt, having SI unit radian per second. And when a body moves in the circular path, the direction of the motion or the direction of the velocity is always tangential to the circular path. So, this is the radius of it. So, this is the linear velocity. So, what is the relation between the linear velocity and the angular velocity, which is given by v is equal to r into omega. Linear velocity, radius, and then omega. You can even write in vector form omega is v is equal to omega cross r. So, I have given this example for cross product of two vectors. So, linear velocity is the cross product of angular velocity and the radius vector. So, that is the relation between the two velocities. And whenever a body moves in the circular path, there is a continuous change in the direction takes place. So, as you all know, the body cannot change the direction by itself unless an external force acts on it. That means there is some force which is acting on the body, which acts along the radius toward the center of the circular path, and we call that force as a centripetal force. And the corresponding acceleration is called as a centripetal acceleration, which is given by F is equal to m into a, where m is the mass of the body and a is the centripetal acceleration. What is the direction of that centripetal acceleration? It is still along the radius towards the center of the circular path. So, in today's topic, we are going to derive an expression for centripetal acceleration, and once you get the acceleration, you can very easily find the expression for centripetal force by multiplying by mass. So, for that I am going to consider first a body moving in a circular path. Let O here be the center. This is the initial position of it, which is A. At that point A, its velocity is always tangential, which I am going to consider v. And from there, it moves to another point B, which is very close to A. This is still r, which is the radius. At that point, its velocity is here, tangential again. So, our aim is to find the change in the velocity as it moves from A to B. Here, we cannot directly subtract, it is not v minus v. Change in velocity is not v minus v. Why? Because these two are vectors, they are in different directions. You can subtract them only if they are along the same direction. So, to find the change in velocity, first I am going to consider that as the body moves from A to B, it describes a very small angular displacement, which is a theta in a time t second. Just draw the vertical here and then a horizontal. And now, if this is a theta, even this angle is also theta here. Okay. So, this angle, alternative angle theta. Then this radius and the vector are a 90 degree, correct? So, this one and this are 90. Therefore, if this is theta, then this will be 90 minus theta, correct? Again, this is vertical, this is horizontal, angle between them is 90 degrees. So, if this is 90 minus theta, then this angle will be equal to theta. So, the purpose of measuring that angle so that we can resolve this velocity into components, resolution of the vector, splitting of a vector into two components. So, if this is v, if this is theta, then this will be v cos theta. It will be like this, and this will be parallel to this, okay? And here it will be V sine theta. So in this derivation, we are going to assume that when theta is very small, so sine theta value is approximately equal to theta. Okay, that is only when theta is very small. And when theta is very small, cos theta is approximately equal to 1. So we are going to use this data or information while solving or while deriving this particular equation. Okay. So now look at this here. At A, the velocity is exactly horizontal here. There is no vertical velocity, okay? There is no vertical component here along this. Here it's exactly horizontal, which is V cos theta, and along the vertical it's a V sin theta. Therefore, the change in velocity as the body moves from A to B. So I'm going to write, let this direction be C. So change in velocity parallel to AC. That is this change in velocity parallel to AC. Now that is equal to, here it is a V cos theta, here it is V. Therefore, it is a V cos theta minus V, final minus initial. As it moves from A to B, this is the final velocity, this is the initial velocity, V cos theta minus V. That is equal to, when theta is very small, what is the value of cos theta? Cos theta is approximately equal to 1. So this is V into 1 minus V, which is V minus V, which is 0. So what we have concluded here is that the change in velocity parallel to AC is 0. That means there is no change in velocity along the tangent, okay? That is what the conclusion. So what do we conclude here? There is no change in velocity along the tangent, If there is no change in velocity along the tangent, means there is no acceleration, because what is acceleration? It is the rate of change of velocity. Therefore, there is no acceleration along the tangent. Now, what is left? So, this vertical velocity is left, correct? So, therefore, now let us write change in velocity parallel to AO, okay? Change in velocity parallel to AO, parallel to this. So here it's a V sine theta minus, there is no velocity along this direction, that's why it is 0, which is V sine theta only. But when theta is very small, sine theta is approximately equal to theta. That is a V, instead of sine theta, now we write it as V theta. So now you can see, we find that there is a change in velocity parallel to AO, which is given by V into theta. Therefore, there is change in velocity along this direction, which is nothing but radius towards the center, along the radius toward the center. But what we have found is change in velocity. How to find rate of change of velocity? But that rate of change of velocity is nothing but acceleration, correct? Which is equal to change in velocity by time. What is the change in velocity? V theta divided by t is the time in which that change takes place. Now, theta by t is nothing but omega. So therefore, here we are with an expression A is equal to V omega, is the expression for centripetal acceleration. So rate of change of velocity is nothing but acceleration, and this acceleration itself is called centripetal acceleration. But we also know that V is equal to R omega, right? So replace V is equal to R into omega. So we get R omega, again omega, so we'll get omega square. So this is another equation. We can even write omega is equal to V by R. Omega is equal to, this is V, omega is equal to V by R. So what do you get? V into V square by R. So this is how we get three different forms of the centripetal acceleration, which and all? A is equal to V omega, A is equal to R omega square, and then A is equal to V square by R. See, once we get the formula for acceleration, we can very easily write the formula for force, because F is equal to m into A. So, m into A is nothing but V omega, m R omega square, m V square by R. So, these are the two different forms of expression for acceleration and the force. Okay. So, what is the formula for acceleration? A is equal to V omega, A is equal to omega square R, A is equal to V square by R. Then what about force? F is equal to m V omega, m omega square R, and then m V square by R is the formula for centripetal acceleration, and this is the formula for centripetal force. Important derivation, it has appeared twice in the examination. And now let us solve some numericals based on the concept centripetal acceleration and centripetal force. So, go through the statement. The statement is, an insect trapped in a circular groove of radius 12 centimeter. So, value of the radius is given, which is 12 centimeter. We have to do the conversion. Divide by 100, 12 by 100, which is 0.12 meter. Moves along the groove steadily and completes 7 revolutions in 100 seconds. So, it completes, the number of revolutions is 7 in a time of 100 seconds. From that we can find always the frequency of revolution, which is number of revolutions completed in 1 second. So, n by t. N is 7, t is 100. So, we get 0.07 hertz is the unit. So, we have found the frequency. First option. What is the angular speed? Angular speed means we have to find omega. Omega we can find using 2 pi f. 2 into pi, 3.142. F is 0.07. Okay. So, we can calculate this. It is a 2 into 3.142 into 0.07, which is 0.4399, that much omega. So, the SI unit is radian per second. Now, that is the angular speed. Okay. And then we have to calculate the linear speed. V is equal to R omega. R is 0.12 into 0.4399 into 0.12. So, that will be 0.05278. So, that is the speed. So, that will be in meter per second. So, we have found the first option. Okay. What is option B now? Is the acceleration vector a constant vector? See, acceleration, yes, it acts along the radius toward the center, but it continuously changes, See, once it acts like this, then it acts like this, then it acts like this, correct? So, its direction is changing. It was here and now it has changed. So, that is why it is, we can say that, is the acceleration vector a constant vector? The answer is no, because its direction changes at every instant. Then, what is its magnitude? So, we can find the magnitude. A is equal to, we can find using the various options, we can find using A is equal to V omega. So, the value V is here 0.05278 into the value of omega is here, which is 0.4399. So, 0.05278 into 0.4399. So that will be 0.02322 acceleration. So it is a meter per second square. Right. So hope you have understood. You can use the other formats also, like A is equal to V square by R can be used, or A is equal to omega square R, that also can be used. Okay. Right. So easy problem, direct substitution. So hope you have understood the various cases. And then remember, moment you find frequency, very easily you can find omega always using 2 pi f. So the next statement, the next question. Question. An aircraft executes a horizontal loop of radius 1 kilometer. So radius is 1 kilometer. So it is 1 into kilo means 10 power 3 meter, or you can even write 1000 meters. With a steady speed of 900 kilometer per hour. So speed is 900 kilometer per hour. So we'll do the conversion. 900 into 5 by 18. This is 500 here. 5 into 100, and then 9, this is a 2. So 500 by 2, that will be 250 meter per second. So that's V. Compare its centripetal acceleration with acceleration due to gravity. So first we'll find the value A. A is equal to V square by R, because V and R are given, that's why I'm using V square by R. It's a 250 square by R is 1000. 25 square is a 625, and then 00 divided by 1000. So this is 62,500 divided by 1000 will be 62.5. So that will be the acceleration. So meter per second square. Compare means we have to find the ratio. So A by G, A and then G. A is a 62.5, G is a 9.8. So on dividing, we'll get the ratio. Okay, 62.5 divided by 9.8. So this will be 6.378. So it is a ratio. So that's why there is no unit for this particular ratio of the two. Okay. So understood the numerical. So conversion is very important whenever you solve a problem, otherwise you are going to get 0 mark for the calculation. So let us again try one more numerical. So this will be the last one of this particular chapter. The question has appeared in this year exam, and in the next class I am going to start one more lesson. Before that there will be interactive session as well as a test soon. Okay, the date I am going to announce it at the earliest. Right, so let's complete the last problem of this particular chapter. A stone tied to the end of a string 80 centimeter. So that acts as the radius of the circular path, 80 centimeter. Conversion, 80 by 100, which is 0.8 meter. In a horizontal circle with a constant speed, if the stone makes 14 revolutions, so the number of revolution is given 14 in 26 seconds, in a time of 26 seconds. So you can find the frequency, number of revolution by the time, that's 14 by 26, 14 divided by 26. So that will be 0.5385, 0.5385, that will be in hertz. So moment you know the frequency, omega can be found always very easily using 2 pi f. 2 into pi is 3.142, which is 22 by 7, and the frequency is 0.5385. So 0.5385 into 2 into 3.142. So we'll give you 3.384. So that's the value of omega, which is in radian per second. So what to calculate? So then what is the magnitude and direction of the force on the stone? Okay. So we have found the value of omega. and we need mass here. Is it given? Title in a constant speed. If the stone makes 14 revolution, then what is the magnetic direction of the force on the stone? Right. So we'll write the mass of the stone here. We'll include it if it is we'll give 10 gram is the mass of the stone. So omega is given 3.384 radian per second, and so you have to find the force. So force is equal to mass into acceleration. So we know the value of omega, we know the value of r. So that's why I can use m omega square r. M mass 10 gram, 10 gram. We have to do the conversion. It's a 10 divided by 1000, which is 0.01 kg. So that's the mass 0.01 kg into the value of omega, which is here 3.384, square of it into the radius. Radius is 0.8. So let's calculate this. So 3. Square into 0.8 into 0.01. So that will be 0.0916. We are calculating the force, so that's why it will be Newton. So that is the answer for the given question, because without the mass it's not possible to find the force. Okay, we can find only the acceleration, right? So that's missing in the exam. Obviously the data will be given. Okay, in case if that data is missing, then you cannot solve the problem. Obviously you will get a grace mark if the question is wrong. So anyways, I have completed this particular chapter. Hope you have understood this entire chapter. A very important chapter from the exam point of view. A lot of derivations are there. So some of them they haven't submitted the notes yet. Okay, so for those students, so there won't be any exam unless you submit the notes. I will not allow you to write the exam. That is one thing. So that's why first complete your notes and then start preparing, and then if you have any doubts, you are welcome to clarify your doubts during the interactive session. I will continue this topic, not this topic, the new chapter in my next class. So before that, start preparing and get ready for the coming examination. Okay, all the best.